I'm gonna have a time. Okay. You said you have to go to streaming on your YouTube? Yeah. I haven't tried that before. How hard is it? It's not hard. Right cable, right camera, right sound. Hello, hello. Hello, everyone. Hello, hello, hello. We about to get started. Everyone can take your seats. We about to get started. Hello in the back. Thank you. We about to get started. Come up. We have plenty of room. Come up. Come up. We about to get started. All right. Awesome. Awesome. All right. The crew in the back by the refrigerator. Hear me? We about to get started. Awesome. Welcome. Welcome. I have a little spill, and then we go into our demos. Sounds good? Awesome. Great. All right. All right. I'm Wayne Sutton, head of community at Convex, and thanks for coming. I know the weather's nice. We start to get some beautiful like sunsets. So thanks for coming out. But if you didn't know that this is our first AI CodeGen full stack meetup at Convex. And so thanks for joining our first one. We're gonna do these monthly or bi-monthly and see how it goes. And for those of you who are new to Convex, Convex is the open source reactive database for app developers. And if you didn't know, also, you can now self-host Convex, and Convex is open source. But tonight, we have 4 demos, and we're excited to hear from our speakers. And up first is Elliot, the co-founder of Chalk.ai. All right. You can do better. You can do better.
Thanks, Wayne.
There we go. There we go.
All right, well, I'm gonna tell you about Chalk. We are a query planner for computing feature values in real time. So this is really useful in applications like fraud, where you're trying to spot if a debit card transaction should go through or not. We're processing about 1/3 of the world's debit card transactions. It's really useful in things like e-commerce, where you're trying to make recommendations in real time as people like tap a screen or say yes or no to some content that you show them, like with Whatnot or Turo or Apartment List, where we do kind of more of the like traditional Rexis use case. And I guess what's really different about us is that we really care about what you can run like in the moment. And so what does that mean? I think a lot of people, when they talk about real time, they really think about streaming. But really streaming, I would say, is kind of more like near real time. It's like whatever you put on that topic, and then it went around in a little loop and ended up in some kind of transactional database for you to read from. But it's not actually like going to the source of your data or like running a function in the moment. And so what we do is we figure out how to run your Python UDFs, your SQL queries against the databases where the data actually lives, and your things like aggregations in forms of expressions, and also things like LLM calls, and then execute it at the moment you need the data, like just in time. So I'm going to show you a quick demo of kind of what that looks like. So we're going to lay out a little bit of a schema for our data. So we've got users in this example application. It's kind of like a fintech use case where we'll have credit reports and transactions and users. And they've got some simple scalars like IDs, emails, names that we're going to pull from a Postgres database. But they've also got some stuff we'll compute via Python functions, like what's the email username for this particular user, or were they deny listed? These are all going to be features, so we can request them to go like feed into an ML model. And some of those features are really particular, and they describe things like joins. So for example, I'll say that my user has a credit report ID feature, which kind of maps to the primary key on another one of these classes. So kind of like something like a Spark, you can write these types of expressions like, oh, count up the trade lines that I've got, or sum the balances over the trade lines. There's also kind of built-in functions that are accelerated, like, oh, I want to know like the Levenshtein distance between the user's name and the memo, for example. So that's a little bit of kind of like laying out the data schema itself, but then we can go connect it to real-time sources of data, whether that's Python UDFs or SQL. In the case of SQL, what we can do is just write a SQL query. So in this example here, I'm going to connect to my Postgres database where I'll pull down a bunch of transactions. And so this is just a plain SQL file with these two special comments. And this first one is saying that I resolve part of the class transaction. So what does this mean? It means that the columns here, like ID, amount, user ID, @memo, are going to also appear over here. And when we need to go get data about transactions, we'll actually run this query instead of like some ETL process that's going to bring it into a feature store that's high performance and conserve this. We'll also do things like push down filters and projections and some aggregations. So you're not going to be like rewriting this query for every like use case you have. If you need to pull transactions for a user, we'll push down a filter that just gets them for the user. If you want just one of a specific ID, we'll push down a filter kind of like that. So that's the SQL side. But you can also integrate this really nicely with Python UDFs. So for example, if I wanted to write a function that I could like either backfill or run in the moment, I could put this little decorator on here online on just any old Python function. And the annotations are going to be a little specific here. So for example, I'll say that this function get email username, which is going to try to pull out like the part before the @sign, takes in a string, but like a really specific string. It takes in the user's email. And it outputs like also a string, but again, like a really specific one, which is what's the email username. And the mechanism for doing that is just this Python function. So I'll like take the email and like split it at the @sign and take the part before the @sign, and then I'll check if Gmail's in it because they've got some funny things where you can like put a plus and then have a million aliases. And I'll just return the lowercase as kind of like the canonicalized version of this. Downstream of this, I could write another function which like checked if that email username was in a deny list or something like that. So I've got this email and deny list function. Maybe I want to change it to say also take in like the username. And I'll say that either the email's in the deny list or the username's in the deny list. And so now we can go query for some of this data, and all of this orchestration will kind of happen automatically for us. So if I go run a query for a specific user, I'll get back all of the features that we know about them. We can also request more data back. So if I wanted both the user and maybe like the transactions for the user, I could pull down all of that information. We'd get like a lot more data. But the idea is we could just determine at runtime what we need to query plan, which kind of takes us to a query plan. So what is that? Well, if you've ever run like Postgres explain analyze or looked at like the Snowflake query plan viewer, that's what we're doing here too. We've got things in here like joins and filters and projects. And we're orchestrating all of these functions to figure out like what needs to run by way of hitting SQL, what needs to run as a Python function, also like what expressions need to run. We really care about latency, and we do a lot of things to make your code run faster. One of the really cool things that I wanted to show you is just that we'll be able to turn Python functions, like large class of Python functions, into expressions. So for example, we were looking a minute ago at this get email username Python function here. And actually what ran for us was this expression. It was this thing that said, well, we need a lowercase whatever the result is, which is an if then else of checking if Gmail's in the string or not. And if it is, then we need to split the string at the @sign, take the first bit, and like replace some of it, the portion of dots, and else we're going to do something else. So this ends up turning into, we parse the Python AST and turn it into an expression so that we can run all of it in C++. And what's really cool about this is it's just like a totally unfair advantage against running in like the Python GIL. Like if you want to backfill this over 10 million or 10 billion or even 10 trillion users, we can do this in just C++ in a really distributed way, where with Python, you get really stuck behind the gill. So we really care about the performance of all these things. The other piece where we were able to kind of make some unfair gains is that in all of these SQL connections, like these SQL files we're writing, we're using the native database drivers. So in this case, we're using like libpq to go talk to Postgres. And for Redis, we end up using a Rust library that works really well. So that's a little on the performance side. On the developer experience side, it's also really easy to deploy this stuff and try it out, both in the past and right now. So for example, we just wrote an update to this function here to check if an email was in a deny list. And we can deploy this software to what we call a branch. So what this is going to do is package our software up, put it on a Kubernetes cluster in a way that's very scalable, but not kind of impact our production deployment. So when I go query for my user this time against my branch, we'll be able to see in the web that we had the new data coming into our function in order to compute the deny listed feature. So when this query returns for us, we'll go click on the query plan link here. And if we look where we're running the email in deny list function, we can go check out the inputs. And we can see this time it's taking in both the email as well as that email username. So this lets you experiment with things and try stuff out really quickly and see kind of what's working and what's not, and iterate on that. You can also do this for brand new features. So for example, if I wanted to make like a fraud score, I could take in the data that I want to have. So maybe whether or not someone was deny listed, for example, and their like match score, or anything through the user. So if I wanted to kind of like access data by jumping through the feature relationships that I've set up, I can go make this Boolean feature here and write out my new function and deploy this to my branch, and then query for the data. And this time we'll see our fraud score function run, which kind of wasn't in the graph at all before. We've got 18 seconds. We're going to make it. So here's our is fraud coming back for Nicole Mann. She's out. We're not lending to her. Well, that's my time. Thank you all so much.
Awesome. We'll take about 3 minutes of questions. Any questions? Yeah. Yeah.
I'm curious how it seemed like the Python types, which in my head like don't affect the runtime, seemed like they were pretty important in determining like what happened, like what chalk does. Oh, for the screen. It seemed like the Python types, which I guess in my head don't affect the runtime, seem to affect like pretty heavily what chalk does. Like how, like what, I don't know. What are your thoughts about this?
Yeah, you're totally right. I think a lot of like pipeline-based things that you look at, like a Spark or a Dagster or something like that, you're orchestrating functions. And you're usually orchestrating functions like pretty explicitly, although some of them you'll kind of like stitch them together at the end. We're really thinking more about like, well, how do I just orchestrate my data? And if I just like thought about like, how can I take in 2 pieces of data and produce a new piece without thinking about how it fits into the whole pipeline, it's a little easier to kind of compartmentalize there. I think the other thing that can be really nice about that is that you don't have to like make a new pipeline for each model you run. Like I ran this query which produced like a bunch of data, but maybe I just want to run a query for, I don't know, like whether or not the user was deny listed and nothing else. If I go look at the query plan that gets run for that, we're actually just going to see something really simple where we go to the database and then we run a Python function. So if you can to express your dependencies in terms of data instead of in terms of functions, it's really easy to have like composability of these things and even query like from different routes. So if I wanted to query like from the perspective of a transaction, I could get like just the data about the transaction, or I could say, give me like the user as well as the transaction. And then I would get both of those objects, but like kind of composing all these functions in a different way because I'm accessing from a different entry point.
Awesome. Any more questions?
Cool use of types.
Oh, thanks. We really like types.
Cool. Hey, Tom, last one.
Okay. So a thing you could do with a DAG is say, hey, I invalidated one of these pieces of data. Do you do any of that kind of push kind of signaling with these things too? I guess that's another thing in my mind real time can mean instead of just fast, which is actually, it was also pretty cool.
Yeah, absolutely. And I think where we end up seeing that a lot is actually on the recompute side. So if I just made this like new feature on my user that's talking about the fraud score, I could ask about recomputing that user.isFraud for each transaction, and I could choose to sample some of the data and rerun some of it. So if your data in your tables is like already well timestamped, you could just recompute all of it. If you return what we call a feature time column, but you just say like, oh, this is the canonical timestamp for this like particular function or for this data source. You could also say, you know what, I only want to invalidate some of it. Like I want to recompute the transaction.user.isFraud, but the rest of it, I just want to sample historically and say like, what were the values the last time we ran this? And then this will just give you like a table back of that data at the end to say like, here's what it would have been. And because these, like, there's no reason we couldn't have been running get user is fraud in the past, so long as these things were also temporally consistent. So we'll go kind of run the sampling and then rerun your function.
Awesome. Thanks, Elliot.
Yeah, thank you.
All right, cool. All right. Great. Up next, we have Gabriel, who's going to talk about building a Ticketmaster alternative for touring artists, a solo developer's journey. This is where we need a background music. Got it. Displays and then
displays.
Yes, preference displays. Cool.
All right. Hey everyone, how's it going? My name's Gabriel, and I've been building a very cool product called Tourest, which is offering fan-funded concerts for touring artists. Before I dive into it, I kind of want to talk about this whole vibe coding thing that people have been talking about. A couple days ago, Wayne shared this hilarious meme on the Discord of, it was like a vibe coding meme with Rick Rubin's face on it. And I've been trying to figure out what this whole thing is. And one morning, I made my coffee, pressed the button, then took out my phone and hit the clean everything button on my Roomba and started cleaning my apartment. And I was just standing there kind of watching these machines carry out processes that had been defined at an earlier time in an explicit manner. And then that's when it hit me, vibe coding, Convex. For 3.5 months, I've been building a product that is not only storing relational reference IDs to other data, other documents in the Convex land, but I've been storing reference IDs that point to external services that do the work. And so for 3 months, I've been building a product that relies on other services to do the work. So if you've been using Convex, you may be familiar with kind of this deterministic sync between the Convex cloud and the clients with these use query hooks and mutations where we have these transactional guarantees. And as Jamie talked about in his video, we have client libraries that store, or they don't cache values, they cache subscriptions in the form of a WebSocket connection to this Convex cloud. That alone was enough to make me have some very impactful career changes. But where it gets even more interesting than that is these Convex actions that allow us to kind of go outside of Convex land, talk to third-party APIs, and then hook back into Convex. So without further ado, I want to present Tourest. So I'm going to go ahead and log in. And my favorite thing to do is actually, apart from playing the guitar, is watching this Convex dashboard just absolutely shred. So we're just going to have this Convex dash open. Tourist. All right. I'm going to log into a user that I already have. And this gives me a dashboard where I can create a team. I'm going to make Bon Iver a profile. Now, with this Bon Iver profile, I'm going to copy link to the artist. So I'm going to point out when we're stepping outside of Convex land and when we're back in. So right now, I'm collecting data. I'm executing a client-side action to talk to Spotify API. I'm getting an image. I'm storing that in client-side state. I'm declaring a city where Bon Iver lives. Got a Google Map API, but that's not a Convex-related thing. Our project is my bio. I can go ahead and create some custom links. Just a website. Maybe I'm trying to sell some merch. I want a Spotify link, maybe an Instagram. At Convex, hanging out. I need to get a Discogs URL for the official discography. Create band members. I'm going to publish a profile. Now, let's take a look at our data. We've just created a profile that houses Bon Iver's data and has a reference ID to the Spotify API with this info object right here. That's a fully typed, it's a fully typed object using TypeScript as my validators, and I'm going to talk about TypeScript in a second. The really cool thing is that this is all super fast. So if I create a change, you can see that there's queries and mutations in action right there. And then I'm also declaring an index on this profile for my access patterns to act as a clean URL where I have a public-facing profile for artists that can showcase all their music, all their links, their bios, and then last but not least, which I'm going to get into, post upcoming performances and create funding campaigns to play in different cities and enter new markets. Right now, a ticket, if you go through Ticketmaster, an artist is getting 20% of that cut. So we believe that we can have a profound impact in this industry and create a disruption. I want to keep talking about this Convex land and stepping outside with Convex actions that write back into Convex with mutations. I'm going to go on tour. I want to play Sydney, Australia, but it's a huge chance for a promoter to go in on that yet, so I want to recoup the funds right away. Live in Sydney, night 1. I'm going to select the time. I'm going to pick my birthday. And I want to play an 8 p.m. show. Sydney. A Convex action receives a geolocation from Google and executes a call to the time zone API. I don't want a user to mess that up because I know they will. They're going to say EST on Sydney, and we don't want that because we need to normalize a UTC date stamp and store it inside of Convex for our start at property. I'm going to create a ticket price of $1 because I'm no longer on my Stripe test mode. A ticket limit of 10. It's a super exclusive show, and a funding goal of $2. All right. And I want to get my funds by April 23rd at 12 p.m. And here's my event. Now, On my public-facing profile, I have a campaign that just published that displays my event data inside of this timeline. And I can also go to this event page in a similar manner as my profile that exposes a slug as an access pattern, as an index on my data. So this user, again, another Convex action right here, my personal account. I go to my settings, my billing. I've already gone through one payment, so I've saved a reference to my Stripe customer ID with a default payment method. This is, again, another Convex action being executed straight from the client and retrieving my payment information. So I'm going to use this user to make a pledge. And I want to be conscious of time, so I'm going to go pretty quick. There's a lot more I want to talk about with TypeScript and stuff, but this pledged payment is very interesting. It's not a payment hold. It has nothing to do with that. It's a record in our database that points out a Stripe customer ID with a default payment method that can then be captured in an off-session manner. If I go to my Convex dashboard and we're watching this thing shred, we've got my payments table right here, and you can see that there's a new pledge created with this amount that points to this user ID, which houses this Stripe customer, and we abstract that with a default payment method, and no payment intent ID yet, which means that this is not a captured payment yet in Stripe. I'm going to go ahead and log out because I need to make another pledge of $1 so that I can get my $2. And I'm going to attempt with a brand new user I've never ever used before in this system to see how it does. I'm going to go back here. Now this user has never been here before. There's no Stripe customer ID associated with them. If I pledge a ticket, I should go through a Stripe checkout session to collect that information. That has a webhook. Ooh. All right, I'm going to work on that tonight. I'm going to go ahead and sign up. And I'm sorry about that, guys. But I'm going to... all right. That was courageous of me. This person already has a Stripe customer. I don't know why I did that at a demo, but hey, that's what I'm here for. It worked on dev, which is no excuse. All right, I'm going to pledge another ticket. And I just want to put open up another tab so you can really get the sense of the power of this reactivity. Assuming thousands of, hundreds of transactions happen every second, we want everyone to be looking at up-to-date data. I didn't see that progress bar move there, but this tab just moved it without any browser refresh. So now we're at a funded campaign. I'm going to log back with my Amarillo email that has a reference to, that should be rerouting me. My Amarillo email is a member of the Bon Iver team, of course, and I can manage all the events there. So now, this event is no longer active. It's in the funded column, and I can go ahead and confirm this event. I want to play at the Sydney Opera House for 2 tickets, for 2 people, 2 very lucky people, and both of them are named Gabe. Presumably, this is the venue portion I haven't built out yet, but there's going to be an invite that has a status between the teams, the venue team and the artist team, where this is approved. This is the most important button of the whole app. This is the cornerstone of everything. What we're going to do, we're going to confirm the event. We're going to toggle the statuses on the campaign, the event. We're going to publish to Luma. We're going to add all the campaign pledges as guests on this Luma event. We're going to execute these off-session Stripe transactions, and we're going to email them a ticket so they can get scanned into the event. So let's look at our Convex dashboard. I know I've got like 2 seconds left. But this last event, I've got it confirmed. I've got a Luma event ID that points to it. If I look at Stripe, I've got 2 $1 transactions that were just executed. And last but not least, if I get to my email, sorry, I'm showing my email. I've added this person as a host, and then my Amarillo email. Where's my ticket? Come on, come on. Oh no. All right, let's see. Luma, Sydney. All right, well, something happened, and I'm still working that out. And transparently, you know, I got the payments working last night, and there was a huge text messages from Chase Bank with fraud prevention because these off-session payments are really tricky. So there's a lot I'm working out. But look out, if you're on the Discord, I'm going to be publishing the first campaign to the Convex Discord community, and this is how I'm going to grow this thing out. And I'm super stoked about this because I think this can have a really huge impact and have a pretty profound reallocation of capital towards creative work and artists. Thank you so much.
All right, we're going to take one burning question. You mind a burning question?
So besides Convex, did you use anything else? Like, what was your stack for the vibe coding of all of this?
Well, the front end is only ever talking to the Convex cloud. The Convex cloud is executing these processes that point at different services and with queries and mutations and actions. And yeah, so yeah, just Convex. Oh, the front end, React, TypeScript. I didn't get a chance to talk about TypeScript. I could talk forever about this stuff, but yeah, TypeScript, Shad CN as a design system is pretty sturdy out of the box, and React and Tailwind, and some radix primitives. Yeah.
Awesome. One more question. Any questions? All right. Oh, in the back. Watch your head. Watch your head. Oh,
I don't think that actually hurt.
Yeah, wanted to ask you, how long have you been working on this? Like, what's the background on this particular project and your connection to it?
Yeah, I've been working on this for 3 months. My connection to this project is I actually built BandLink for the hackathon a couple, like 8 months ago, and this is kind of the first prototype of this idea. I saw my friends that are musicians all over the Bay and over the country. Instagram Reels are the lifespan is so short. People don't have it's so ephemeral. People don't have a place where they could just showcase their work, and building a platform that elevates the artist. And so, I linked up with a client that is looking for this kind of work, and we jammed on it together. And yeah, 3 months of work on Tourest, which I think is pretty outstanding. And Convex is great because I've been building the product. Just building the product. Yeah.
Thanks, Gabriel.
Yeah, thank you. Thanks, Wayne. Thanks for having me.
Oh, yeah. Awesome. I promise everything is not Convex pitches, even though we're here. So, but up next, Tom is going to talk about some of the things we're doing with what Convex is doing with the AI. And after Tom, we have Daniel from trustgraph.ai. Here you go, Tom.
Great.
Yeah. All right. How's this? Looks okay. Great. I even got a thing. Oops, that's a spoiler. I hope you didn't see that. All right. I want to talk about mistakes that I've seen Cursor make, and I'm kind of new at this. I have not been doing a lot of let's see, about, when was it? Maybe 2 years ago, I was like, okay, I finally get it. I'm excited about LLMs. They're pretty cool for other people. Like, I think this is going to really change things, but I was not writing code with them. And I've never really gotten to the code completion stuff. They're like, all right, I'm really into TypeScript and hitting something dot and seeing a bunch of stuff pop up. I love that stuff, right? But I'd never really gotten into writing something, like writing a comment and then the very fancy tab stuff that Cursor does. And then really just in the last, actually the only thing I've been using LLMs for while I'm coding I chat with Claude for sure, right? I'm always talking to LLMs, but only writing code, the only thing has been this guy here, where sometimes I want to do something and I don't remember the command line flags to do it. And so I just type out, all right, I don't know, list all the files, the txt files in this directory and up to 2 levels down. And could you do, a lot of people probably do this. I guess I could do a shell expansion. All right, I could do it with a find, but the find flags I never remember, right? So I don't know how to do this without looking it up. And the only thing I'd done until a few weeks ago was I can hit a hotkey, and then that passes it to an LLM. This project called LLM Command by Simon Willison, which is doing like all kinds of great LLM stuff, great blog. And I have it hooked up here, and it says, great, it's -max depth. I had no idea it was max depth. And if I did, I still would have put 2 dashes, right? There's no way I'm going to remember this annoying single dash stuff. So that's great. And I can run that and see it run. And then I add it to my shell history. And then I recently changed it, so I also add the prompt to my shell history. Because there's nothing worse than being like, oh, I got this, but I want to change the prompt. And you're like, shoot, I don't have it anymore. So now I save that in my history too. And I can go back and say, list the first line of all those and prompt again. Anyway, but that's all I'd done. I'd never done this. What I think of AI coding, maybe that's what it does. I don't know. Nipun said commands, so sometimes you can pair with him, but I don't myself. I just know they exist, right? But that's the only thing I'd done with it until about 4 weeks ago when at work they're kind of pushing it. I might be the most curmudgeonly. I'm close. I'm not quite the most. I'm near close to most curmudgeonly at work, where it's like it's time to do this. So how I've had this set up is like, great. I'm using cursor. I'm using agent mode. I'm using YOLO mode, where it's just pretty scary. It's just going to run commands without you getting to confirm them at all. And I am not vibe coding yet. I'm not there yet. I'm not yet to a point where I can say, hey, do this thing and not think about implementation. I'm absolutely thinking about implementation. I am thinking, I would write code like this, and then I describe approximately what I want, and then I get an edit of about up to 100, 200 lines, right? And I don't have to model this probably. Most of you have tried this kind of thing, right? Like I have this thing up here, and I say things like, hey, could you change let's look at my other one. Hey, I've got a Convex app running somewhere. Maybe it's here. Yeah, right. It's Convex, pretty cool. It's reactive. I'm not going to talk about it. Send messages, and then I can say, hey, could you change the messages to be all uppercase when rendered? And I have all kinds of spellings that just doesn't care, right? It's just going to do it. Critically, in the background, we're running this Convex dev command. It says, great, it found some stuff. Oh, no, that's not what I wanted. No, it's doing it on the front end. Stop. No, on the back end in the query, please. And hopefully do that instead. Yeah, not the front end. I want this rendered. I want to show off how cool it is that if I am looking at, this is tut. Pretty cool that, here we go. If we look at, pop it back, great. Okay, it looks like it's working. Who knows what it changed? If I was really vibe coding, I would just accept all. And that's where I'm not quite there yet. I mean, here, I feel all right about it, but I'm going to go ahead and hit the little button that says inspect changes somewhere. I'm not going to read this, but I'm going to look for the button to review changes, and I will take a look. And yeah, I don't know how to do it with this giant window. There we go. Look at that. Okay, that's reasonable code, right? That's the level I'm at. I'm not yet sitting back and saying, you know what, I wish they'd had this feature. What about this feature? Could you change this? Because I've seen it get stuck too much. And there's all kinds of, right, tons of people are researching this right now. I don't have much to add to what do we do about this. Let's go back. We had a talk here. Yeah, I can't vibe code, it's just stuck. There's all these tools we can use, all these things we can do. We should add some tests. I found that's helpful, right? If it can see the feedback. If you can give it more tools it can run. Convex great for this because I can tell the LLM to say, hey, could you run that function that you just wrote and see if the output looks good to you without even having a test, right? I can add more logging. I can make it optional logging. I can tell it to read the logs and see if that seems reasonable. I definitely want checkpoints. Using version control, right? All the time it does junk and I want to reset it back to an earlier spot. Sometimes I make a change and I tell it to make the diff smaller. I say, like, use get diff and look at everything we've done. All I wanted it to do is this. Can you remove anything extraneous? And of course, when I say that, it's going to remove too much stuff because that's how this. Who's doing this kind of vibe coding, near vibe coding. People playing with this? Okay, so it's maybe interesting to demo, because if you're not doing it, you should be aware it exists. You can do this. It's not quite good yet, but it's so amazing at doing just under good. It's incredible. Right, but it, like, it's a point where you can, it's just so close to being good. Anyway, you can write code that's not used too many places. I found that helpful, which means I get very, shallow nesting, where I have, instead of having code that depends on code, code that depends on code that depends on code all the way down, I just get very branchy stuff where it's like, well, I'm just gonna I'm not gonna dedupe stuff very much. I'm just gonna have it in multiple places, because the cost of changing that code has changed so much. What else? Absolute use TypeScript, right? Because it can see those lengths coming back. You subdivide the code more. This is important stuff, but lots of people are studying this stuff. I want to focus on a very specific problem, and the talk was something about how I fix the problems, right? So let's look at one specific problem. That is getting stuck in a pager. So cursor is going to run a command, and sometimes it'll wait for the command to finish running. And on computers, well, in Unix, there's this thing called a pager, which assumes that since you're in an interactive terminal, probably what you wanted when you run a command that takes too long. So if I say git log here, probably you don't want to spit out all 10,000 lines or 10 million lines, right? You want to have you in this nice little thing, and everyone knows their Vim keys, so I can press J to scroll down this thing, and I can press K to scroll back up. I can press Q to get out of it, and it's a wonderful experience. But cursor has trouble with that, right? When we come in here, I say, hey, do a get log. Don't send it to cat. I'm not to that part of the talk yet. So it does this, right? It says, great, I'm happy to do that. It wastes a bunch of tokens telling me how happy it is to do it. There we go. And then it says, great, and here we go, get log, and sure, pop out the terminal. I don't know, is that gonna help? Not really. It's stuck in a pager here. Okay, this is better though, it figured it out. Because I popped it out, it's now in the background, it can know what's going on. But what I need it to do is not do that. I don't want to pop it out. I want it to look at the output, analyze it for me. I'm trying to step away from the process. So what do? I say, okay, well, what could fix this? I expect new models to have better context. They'll fix this. I think cursor will absolutely fix it. This could be fixed in a week, right? I think that having a model context protocol server will absolutely fix this, because we're not speaking terminal commands anymore. We're going to be speaking this JSON RPC thing, and we'll have different problems. Maybe it'll build invalid JSON, but we'll be in much better shape, right? Shell coding I've seen with this too. It was supposed to be how to fix them. I don't have time to talk about how I fix them, but if I did, what would I say? I mean, not much. What did I do? I just said pipe it to cat. That's the normal workaround. You say, let's make standard out not be an interactive terminal anymore. Just spit out all the results. And that's the solution here, right? That is but what am I going to do? Am I going to add a cursor rule for that? Because the way I'm used to using computers, it's all about like, I'm doing this task a lot. I'm going to go customize, right? And dot files. Does anyone remember dot files, right? We spent so much time customizing our personal experiences of the computer so that they'd work better, right? And we already saw one. Actually, I already demoed it because I'm time efficient. That was where I defined that little command where I said, when I hit Command-Control-R, I want it to, instead of looking through history, send this prompt to an LLM and give me the command back. I have hundreds of those things. I have thousands of them, right? I have so many lines of config files that make my computer work differently than somebody else's. And that's a terrible idea with LLMs. You want it to be the same as everybody else's. And similarly, I'm not writing cursor rules right now because it's just changing so fast. I want other people to do it, right? I just don't think the changes I make when I notice like, I can optimize my thing, and then I'll have this cursor rule sticking around that makes my cursor setup different than everybody else's. So I'm not doing that. There's some evals. I'm expecting other people to do it. Maybe it's cursor, maybe it's Convex. At Convex, of course, we've got a whole team working on, let's make these things really good. It has instructions here, and you can go read, 1,000 lines or so of junk about telling the LLM how to properly use Convex. And the thing is, it's not just the work of writing that. There are actually evals that are saying, all right, are those good? When we change this word to this word, does it get better or worse? And I don't want to do that stuff. So right now, we're not writing cursor rules. I am just trying to vibe code on my own, waiting for it to get better, and then also waiting for the rules provided by these tools to get better. And that's it. Yeah. And anyway, the vowels are important. As a coder myself, I'm not writing these rules, and I'm not finding it useful. I'm curious if other people are, but for me, I'm just sitting back and waiting for it to get better. Okay, that's it. That's what I want to talk about.
Thanks, Tom. Awesome. All right. Any questions for Tom about why he's not vibe coding? All right.
When you, excuse me, when you were vibe coding, did you feel that there was any issue with like maybe an older version of the Convex API? Like, did you ever try say, oh, actually, I'm using Convex version whatever, and the API is different? Did you see that an LLM was able to handle that or not able to handle that?
I didn't have that problem because I was such a curmudgeon that I waited until there was already a team at Convex, like with these evals, building good rules that they told me to stick in cursor. So I did that. I was fine.
And
but
once those rules were in cursor, did you try different versions?
No, I didn't. I just had that updated. So that would be an issue, right? Like, shoot, we're gonna have to build the matrix, right? Of like, hey, this is this version, or it needs to know that, or presumably the cursor rules will need to say, yeah, in this previous version it used to work like this, now it works like this. It's your job as the LLM to look at the version field and see what it is. Yeah, that. Right now it feels like all the problems are solved because I have this up-to-date thing. But yeah, I think that will be an issue for.
Any other questions? All right. Wait, one more. All right.
There you go.
All right. Yeah, I guess I'm curious. So I've been trying to vibe code. I'm pretty like novice to programming in general, and it's definitely accelerated my pace significantly. The hard thing is like sometimes like I don't know what I don't know. So I've been starting to rely on LLMs for figuring out like the structure of how to approach a project, like, you know, just what, like, I guess almost like feature specs a little bit, but more than that. Have you tried something like that? Have you had success with that? Like,
I think that makes sense. You mean like talking prose to LLM, right? And be like,
yeah,
hey,
like,
how should I break
but like
this
to figure
down?
out like
Show
how
me
do
the
I
steps.
like how to approach the project,
Totally.
right? Like in general.
I haven't because I'm arrogant, right?
Okay.
I'm just like, I've been doing this for so long, I know how to
Fair
do
enough.
it. And sometimes that arrogance is borne out where I don't give it enough guidance and it does something that is generally reasonable, but in specifics not reasonable. And so I've kind of been starting really low, like write a function that does this.
Okay. Interesting.
And then moving up to, okay, can you change the code so that it does it this way? Looking at it and being like, no, do it this way, do it this way. And then I've heard people doing this, right? And I think that is a dream. That's why I say I'm not vibe coding, because that is what vibe coding is to me. I describe the product and I say, you know what? I wish it worked differently than that. What if instead it was, the producers of the music that had the flow for, donating music to, or donating money to other people making, you're describing an idea and it gets there. And I've seen that work with very shallow stuff, but it's not there for me on existing code bases. Anyway, so yeah, seems reasonable, but no, I guess I'm delivering my very specific experience here, which is a curmudgeon that's just like, I don't want to give it up to the LLMs. And then it is faster at a certain point, and that's why I'm doing it. But in other areas, absolutely. I'm all the time talking to chatbots. Usually it's Claude for me, but like, how does this work? How does this security thing work? How does this product work? Yeah, all the time. Just not yet for software architecture.
Got it. Cool. Thanks.
All right, you can start.
Okay. Thank you for that. That was super cool to hear about your experience with it. Have you tried getting Cursor to plan stuff, like output kind of what it's thinking into like a file that you can edit and that you can like tweak and stuff like that?
Oh, cool.
Yeah.
I have not. I have done like some of the automatic stuff it'll do is I describe a thing I want, then it talks back at me for a while.
Yep.
And I don't have a knob on it though, right? It's just like, oh, it's feeling chatty. For some reason, it's going to run the plan by me this time.
Yep.
Generally, I'm writing a whole paragraph of the pieces I want. And that sounds more effective than what I am doing, right? That's what I was doing with the CLI commands, right? It was like, great, show me the prompt. Okay, I'll modify it. I guess no, but not quite though, because you're saying modify
a artifact that that Cursor produced. No, I have not been doing that yet.
I encourage you to try it. But full disclosure, I run a company called CodeBuff, and that's kind of what we do. Yeah, we have this whole kind of feature that does that, and we found that it works incredibly well when it comes to actually following your direction and doing the things that you want. And of course, you go in there, you modify it as you need, and so it works to what you want.
Cool.
Great. Good job pitching. Good job pitching. Okay, last one. All right. I have ready? I have a story and a pitch. Okay. Quick story is I watched this reel where it was talking about Tony Stark and like take the action, don't wait, take the action. And the back channel story to that is the night that the tweet came out about vibe coding. I shared it in our Discord, I shared it in Slack, like all this thing about vibe coding, people talking about it. I went to domain or the registered domain name vibecoding.ai and I paused. I was like, it's available, should I do it? And I didn't do it. I was like, I get it. I can point it to Convex. I was like, oh, but it's one thing, it might not take off. And here we are in a meetup talking about vibe coding. So buy the domain name, take the jump. You got it? 1 second.
So how do I get it to extend to this one?
All right, so go and click that right here. This one mirror. No, last one.
Oh, okay.
All right, cool. And the pitch is that, and Tom mentioned this, is that we, as you can see, Convex is serious about AI and vibe coding and Cursor. And Tom shared the domain name, a link on our Stack blog where we did some evals. So check that out on stack.convex.dev. And we have a new page. So if you're building an AI app, we would love for you to use Convex because we believe, and we have the benchmarks that the team put out to show that Convex is the best backend for building AI apps. So you can check that out at convex.dev/AI. Last pitch from me. And last demo is from Daniel on Beyond Chatbots, Agent Systems versus AI Agents. Daniel, thanks.
Oh, thank you for having me, Wayne. Thank you. And for now, for something completely different. Also, this is the first I've been hearing of vibe coding. I share all the same sentiments about somebody really needs to jump on that very quickly because that will go viral. How many of you have heard people talk about, agents? I'm sure everybody's heard talk about agents, but you probably also heard people talk about agentic systems. You probably went, what's that? Is anybody else going like, well, what's the difference? Yeah, exactly. Well, hopefully we're going to figure that out. I think, agents are fairly easy to straightforward to understand. Before agents, well, it's an old term. We've had agents for a long time, but the way we're using it in this context is that the old way was when we had structured conditions. We know the set of conditions in which we want to trigger some sort of response. Now, we're taking like two strangers meeting on the streets of San Francisco, and one of them's a tourist. You don't really know what interaction is going to happen. There's just so many different possible permutations. There's no way you could code it all. It'd be incredibly inefficient. That's kind of what we're using the LLM for, is being able to take all those different conditions and then be able to choose a course of action. So individual agents, I think, are pretty easy to understand for the most part. It's very, very specialized. It fits into a single role. If we use this music theme, like our harp player here, this person has probably studied for years on how to play the harp and that kind of particular music. It's a very particular skill set, and it's optimized for that particular knowledge base. And somebody that's highly skilled in it can do incredible work. So if you have 6 of them, does that make it an agentic system? Have you ever gone to see 6 harpists? Probably pretty limited in what 6 harpists can do. It's probably really cool, but you are limited in the kind of music you can play. What an agentic system is more like a symphony. You have all these different instruments, and all these different people, just like the harpist, may have studied for years with very specialized knowledge bases, very specialized skills, very specialized roles to enable them to play a huge assortment of music. So it has that flexibility, it has that modularity, it has so that anybody can call out almost any type of music and a full symphony could perform it. Now, maybe you don't need every single piece of it. You may only need certain instruments, but it gives you that capability, that flexibility. Also, I made these with Imagen 3, and it's pretty scary how good it's gotten at creating these images. That to me actually looks exactly like Davies Hall, Symphony Hall here in San Francisco. I've even tried to come up with a formal definition for agentic systems. So I think what we're looking at is when you have a human request. An agentic system is one in which has all the knowledge bases, all the skills, and the workflow capability to be able to execute and fulfill that request. And what does that look like? It's a combination of a lot of things. Right now, agents do a lot of chain of thought, react. We're starting to see some plan and execute. And then also there's just some people are now saying, well, we know quite a few different tasks that the agent may need to accomplish. Well, why don't we just code those in, with conditional triggers? We know that there's potentially 13 things we want to do. So we can have the LLM basically maybe parse which one of those are, but then still just have a blend of all of these things. And I think that's what we're doing. Well, that's what we're going to see. And as a matter of fact, that's actually what we're doing with TrustGraph. But what does that stack look like? I think we're kind of here right now. Because I started thinking about this. Can I model this like in the OSI model? I think we all, hello. I think we understand, the app layer, the UI UX layer. We understand that, sure. The raw data, whether it's documents, Slack messages, emails, images, video, we got that. But what about all the stuff in the middle? And LLMs, they go in there somewhere. Where do they go? What is all of this stuff? It could be a lot of things. You probably need some sort of data stores for a really scalable, reliable system. That's, tabular data stores. You could have knowledge graphs like we do. You could have vector DBs. Then you have to process all that information. You're chunking information. You're doing ingest, different kinds of structured ingest. You're generating metadata on all those ingest jobs. And, LLMs are in there somewhere. And then you just have to manage all this. You have to manage all the APIs. Then, if you're actually deploying models locally or deploying models anywhere on hardware, you're going to have to manage those resources, whether it's with CUDA, Olama, transformers. You're going to have to manage those resources somehow. And then if you're deploying into cloud, you have to manage how much data storage do you need, all of that resources. And then, oh, by the way, if you're containerizing it as well, that's got to be managed. And then all this has to be connected together. And then that has to sit on some type of control structure. What's actually providing all of the resources for this entirety of the stack, and then gluing it all together with processing queues, data flows, data streams, etc. And what does it look like? I thought about this a lot, and I don't think either of these kind of fits. I don't think it's in layers because I don't think it's nice and linear. I think we have a lot of things that are like over here to the side. We have a lot of like sideways arrows, diagonals. We have some going one way, going the other way. It doesn't fit very neatly into what we think of like layers, although we're starting to see that term. I've actually, I saw one VC blog just this morning where they start talking about different kinds of layers inside the agentic stack. Pipelines, you can think about some as a data flow pipeline, but I don't think that really fits very well either. So the way we're thinking about this is that we built a lot of stuff, and we're calling that a knowledge layer, and all that stuff in the middle, that's what this is. So what is it? Well, first of all, it is open source. It's AGPL3 now. It may be Apache 2 soon. It will never go less restrictive. It'll never go more restrictive, but I think we're going to make it less. It's a full stack solution. So everything in that middle, that stuff, everything is there. Scalable, reliable. It's built on top of Apache Pulsar. It deploys all the data stores, all the connectors, all the modularity and flexibility, and it has the ability to manage the data that you need to load into the system to be able to actually either deploy agents or deploy an agentic system. And actually, let me, since we have a little bit of time, show you, oops, if I hit the right button. our YAML files got kind of out of control pretty quickly. It's fully containerized with either Docker or Kubernetes. So we very quickly realized we need a way to people actually to build these. So we actually have a config portal where you can see all the different options that we have. Docker, Minikube, GCP. We actually have an AWS deploy as well. We just did a workshop on Monday this week at the AWS Loft with our partners Memgraph. You can see them in here along with Neo4j, FalconDB, Cassandra. Quadrant is our default vector DB, different chunking algorithms, and these are all the different kind of model deployments we support. So Azure on OpenAI, Bedrock, AWS Bedrock, and when you go in here, this actually gives you the full list of models that you can deploy in the system. Different kind of prompt tools, then the agent tools, our data workbench, and then if you come here, you actually get all the instructions you need on how to launch it. And I actually have it up and running right now. This is our Grafana dashboard. We're using Prometheus to get data, all the real-time telemetry out of the system. I actually gave a talk not too long ago about how this tool right here, our token throughput, is actually one of the most useful tools we have because it can tell you when you're getting rate limited, which is actually becoming really, really, really common with the cloud LLM service providers. AWS Bedrock, Vertex AI, Google AI Studio will now do a lot of rate limiting. Matter of fact, Bedrock will actually limit you to the point of throttling where you'll get shut down for 5 minutes. So if you don't have any sort of rate limit event handling. And this is our data workbench that shows. So I've actually loaded a data set, which is kind of the last 2 years of NTSB data. So if you've been watching the news and seeing all these airline accidents, aviation accidents, and going, what's going on? Well, this is an interesting opportunity to look into some of that. So if I just pick a random, describe the incident involving, if I can spell it right, involving AA5. This is just one we pulled out at random. So this is actually going to query over, let's see, how much do I have in here? I have over 80, so I have 35,000 nodes and 81,000 edges loaded in the system. We have loaded in Memgraph right now. And if I actually run a query, you can actually see that it's all there. We come back here, we get a response on some of the information involving this one from this very particular data set. If we choose any one of these, we can then start looking at it in actual relationships. We can see how it's all related. We can even look at it in 3D. So we start zooming in here, and we see how all of this data is connected. And if I hit that one, it's going to really explode. But that's another type of, we can see how all these are connected. We can even see the directionality if you click these. And like I said, if I click this one right here, because this is actually the entire incident name, the screen is just going to explode with the relationships. So as I said, very different direction. We're really trying to be that in-between stuff and still trying to figure out, how really to communicate what that stuff is, what that stuff should look like. Yeah, we really appreciate it if you check it out, give us some feedback. And like I said, it's only going to get more open source than it even currently is.
Awesome. Thanks, Jay. Any questions?
How does the data get? Hello. Does this actually work? How does the data get from NTSB into this graph form?
So
automatically, or?
I kind of glossed over that because I don't have too much time. So we actually have what we call knowledge cores, that when you ingest huge amounts of data, it actually structures that as knowledge graph triples and mapped vector embeddings, but we do it in a way that's reusable. So that's why we call them knowledge cores. So we've already created this knowledge core for this entire data set so that at any point it can be reloaded back into the system. And the release we're working on right now in the latest version is going to give people even more granular tools on how to manage data that's loaded into the system. So once you load data in the system, you'll be able to remove certain parts in a very granular way. You'll be able to add more data into the system. That's kind of been one of the things that people have been really, really excited about, is just the boring world of data management. No, we do that. So you've probably seen other people doing, graph building. So our trust graph actually fully automates that. You can point thousands upon 10,000s of documents at it, and it will create the knowledge graph and the map vector embeddings from that with no work from you. So we have a different approach to knowledge graphs in that we're kind of a super flat ontology, which if anybody in the room, I know one of the earlier talks talked about knowledge graphs a little bit. Knowledge graph people are typically very, very in favor of very structured ontologies. And there's a good reason why. A really, really, really granular ontology allows you to do really sophisticated and granular queries. However, vector embeddings and semantic similarity search kind of gives us a cheat to get around that. So managing knowledge graphs now is kind of hard if you have a complex ontology, because all the data that goes in has to be really, really richly labeled. So a lot of effort goes into that. But now with semantic similarity search, we can get an idea of what nodes in the graph are the most interesting to us, what edges or what properties or what entities, however you want to think about it. And then you just create a subgraph from there. So it's a little bit similar to what the light rag paper proposed, but we were kind of doing it before then, so we just never picked up that name. Does that help? Okay.
Last question.
Do you expose open weight models like DeepSeek?
We support pretty much everything out there, and we support OLLAMA and LLAMA files.
Did your users want different features for that set of models, or the same features as the API-based models?
Do the users want different features specific to particular models?
Yeah, like so if you can manage your own weights, you have a lot more control, you can do more stuff.
No, we haven't really focused too much on that level of granularity, because our assumption has mostly been that if you're building your own models, you've probably built a lot of your own bespoke infrastructure as well. So that was kind of just a commercial decision of probably not going to be customers of ours. As we begin to grow and have more resources to attack different problems, maybe we'll look into that. But that's just one we haven't focused on at this point.
Cool, thank you.
Great, awesome. Well, that concludes our talks, our demos. I want to thank all our speakers. Give me a round of applause. And thanks, Daniel. Great. All right, we have plenty of pizza in the back. We're going to turn on some music. Feel free to eat the pizza, network, and thank you all for coming.